where the way to go therefore is, for example, this one, even though that one, remember, I asked you to specifically sum it, right? So you actually get a number. But if you just ask whether this series, you're not required to sum it, just the question is whether it is convergent or not. Then you look at this, I immediately see it's what? Convergent. Why? Because I compare with what? 4 over n squared. Right? Or compare with 1 over n squared. Then you take the, use limiting comparison. The ratio of the corresponding terms stabilizes to 4. Is that right? Which is a positive number. Then if one converges, the other one converges as well. If one diverges, the other one diverges as well. Because 1 over n squared, that series converges, and therefore this one converges. Right? But if you attempt to use, as you did, right, racial test, then it becomes equivalent. All right, so then what kind of example would you use racial tests? Well, you kind of feel it. You see that what this is trying to do is this. You're going from one term to the next. If each successive term, it becomes smaller and smaller in terms of absolute value. Smaller and smaller in size. Apart from the size, smaller and smaller in size. Fast enough. That's the key. If it drops off fast enough, then the absolute value series will converge. Okay? So here's an example. Usually, so this is the next remark. This remark says that don't expect too much. If you deal this with this y class of series, sorry, it has nothing new to offer, right? It is inconclusive. But the next good news is that usually, not always, of course, but I can usually always design some weird problem. But this is just usually useful. So I'm talking about racial tests. Racial tests usually useful when there are in a denominator. So for example, summation 1 over n factorial. Now, this one, in going from one term to the next, it drops off very fast. Why? Look at A1. A1 is what? 1 over 1 factor. A2 is 1 over 2 factorial. A3 is 1 over 3 factorial, and so on. Right? So what is 1 factorial? 1 over 1 was 1, 2 factorial. 1 times 2, right? 1 times 2. So let me write it 1 over 1 times 2. This is 1 over 1 times 2 times 3. So if you look at this, from this first term to the next, you multiply by what? 1/2. From this term to the next, you further multiply by what? 1/3. So this 1/2 means A2 over A1. This means A3 over A2. See that? So these neighboring term ratio, getting smaller and smaller. Now, so what? In going from, say, A10 to A11, you multiply by what? 1 over 11. Right? In going from A99 to A100, you multiply by what factor? 1 over 100. So you see that it drops off very quickly. Okay? If it stabilizes, say, 1/2, 1/2, 1/2, each successive term you multiply by 1/2, then that's already good enough. That's what geometric sequences already converges. Not to mention that this one drops off even more, much more aggressively, right? And so it reflects in this case, you have limit. So if you apply racial test, it said that this one limit an to an plus 1 over an is equal to 1 over n plus 1 limit n goes to infinity. So what is that? 0, right? And so which scenario? 1, right? So this one converges. And actually converges what? Absolutely. Well, of course, it's positive series. If it converges absolutely. But I want you to know that this one is convergent absolutely. If you ever use this ratio test to conclude that something convergent, then it must be convergent what? Absolutely. Under no circumstance would you use this one to test a series, and that series happens to be, to say that it's convergent, and it happens to be what? Conditionally convergent, just impossible. If you use this one to conclude that it's convergent, it must be convergent absolutely. All right? Okay? All right, so this one converges absolutely. And of course, this is positive series anyway, so if it converges, of course, it converges absolutely. But even if I change this one to -1 to the nth power, so that is alternating, right? And then in that case, of course, it doesn't take this to prove that it's convergent. But if you use this to prove that it's convergent, then automatically it's convergent absolutely.
Could you just say it converges by the ratio test, or do you have to state that it converges absolutely?
You just say it converges absolutely. You have to say, oh, I see what you're saying.
Because it's all positive.
Yeah. On an exam, you want to make it clear. So by the what? Ratio test.
But must you include absolutely in that case?
Yeah, because this one. Oh, yes.
The ratio test is always.
I should have used absolute values.
Okay.
Right. Okay. Absolute value set. But this is a positive series anyway.
Okay.
So yes, do use positive absolute value set here. So go back here and add the absolute value set. That's the statement of the. Okay. So this is that. So just keep in mind, this one usually is used. This is one in estimating, in going from one term to the next. You know, what is that bridging factor? And that bridging factor, if after a while that bridging factor becomes something consistently small. You know, it approaches some L. Now, if this L is 1.1. Then after a while, it's almost like from one term to the next, the absolute value it's multiplied by 1.1. That's bad, right? Because essentially make it what? Bigger. Is that right? And therefore it must be what? Divergent. Why? Because if L is bigger than 1, that essentially says after a while, the absolute value series from one term to the next has actually become bigger. And therefore, the individual terms do not what? Converge to 0 anyway, and therefore the original series diverges because of what test? Test for divergence. Right? Okay. And but the bad news here is that there's a wide class of commonly encountered series for which, this is always inconclusive. But if you see n factorial, usually you might want to try ratio test. Not always, but you can consider trying. So let me give you another example. Example. Summation -1 to the nth power, n goes from 1 to infinity, n to the nth power over n factorial. Does that work? Okay? All right, so let's try to see if it works. If you're not sure, at the beginning, you play with it, right? So this one, okay, you can formally do, forget about this sign. So you copy this over here, Right, so one way of doing it is just copy this over here, and then n plus 1 to the n plus 1 power over n plus 1 factorial, right? Okay? But what I urge you to do is to begin to feel it, and that will allow you to pretty much write down the ratio right away. Look at this. Imagine that you go from this one, forget about the sign because you're going to take the absolute value, right? From this one to the next one, what happens to the denominator? Is that bit bigger? Is that right? It goes from n factorial to what? n plus 1 factorial, which has an extra factor, which is what?
1.
N plus 1. And this essentially takes, if you massage this, then you're going to see n plus 1 power over this guy here, n to the nth power, times this one, which goes here, and this one flip it to get there. So if you algebraic manipulate it, and see that these two factorial, they cancel out, you're left with this. All right? Okay. Now, what happens to the numerator? Now, numerator is not that easy. It's not that clean, right? Because what? Because in this term is like n, right? But the next term is what? N plus 1, n plus 1, n plus 1, n plus 1. The factors are different, right? So you cannot do something like this. So let me deal with it separately. So numerator, in going from 1 to the next is n plus 1 to the n plus 1 power, right? But the previous one was what? N to the nth power. So you should expect something like this. This comes from this guy. I'm just essentially copying over. All right, so this is kind of a lot of algebra, but you come up with a way to sort of skim it that allows you to write down the answer more quickly. That will save a lot of time. Now, this one doesn't seem to be easy to maneuver, right? Any idea? What would you do? Can I cancel out one factor of n plus 1 here? Right? Yeah? So that becomes what? N plus 1 to the nth power over what? N to the nth power? Is that right? So what is that equal to? Right? All right? And what is that? Does that ring a bell? What is that convergent to? Anyone? Have you seen this before? This has to do with money. So this I just calculate this, right? And then so now I'm ready to take the limits. So after this computation, now I clean up that ratio. So the limit of that ratio, therefore, is what? Is E. Have you seen this before? Have you seen this limit 1 plus 1 over n to the nth power, n goes to infinity, is equal to E? You know? Why did I say that this has to do with money? Let's say, suppose the interest rate is, say, 3% annually. And what does it mean to compound monthly? So you start with the principal,